Hey, what's up guys? This is second part for section 5.6, graphing inequalities. And in the last video, we talked about how to graph inequalities on a coordinate plane. And just a quick review, inequalities are the four different symbols you guys see on the bottom. And you have to know if when you graph, you have a dashed line or if you're going to have a solid line. And then you guys will have to shade one side of the line, maybe on the top of the line, maybe on the bottom of the line, and then you guys have to explain what the shaded part is. Now, graphing inequalities is the same thing as graphing lines or linear equations. So here's an example. Y is greater than 3x minus 2. The way you guys are going to graph it is the same way as if you have an equation, y equals 3x minus 2. But we're not going to use the equal sign. We do have inequality. We are going to use my slope. We are going to use my y-intercept. And using those two components, we are going to make the line. And then you guys figure out if it's dash, line, solid, or what side to shade. So let's go ahead and look at some examples. So this example here, you do have y is greater than or equal to 3x minus 1. And we want to graph that inequality. So notice I do have my coordinate plane ready. And it's a good thing that y is by itself because we can find the slope. There's the y by itself. We can find the slope right away, and we can find the y-intercept right away. This right here is, you can say, very similar to the slope-intercept form. And I'm just going to write it down on the top so you remember what is the slope-intercept form. Y equals mx plus b. Keep in mind that we are not using the equal sign, but we do have an inequality. So my slope, since y is by itself, I know my slope is the one with the x. So I do have a 3, and keep in mind, also remember that my slope is rise over run. So when I have a whole number, I have to make it a fraction, and I need to know which one is my rise and which one is my run. So this one is my rise, and the bottom will be my run. I go up 3 and 1 to the right. My y-intercept, b, is going to be the number with no x. So this number here, minus 1, is your y-intercept. So you always start with the y-intercept. Y-intercept is negative 1. So I'm going to go to, on the y-axis, the negative 1 right here, and I plot a point. Y-intercept is negative 1. So I'm going to make my point right there. Then from this point, I'm going to use my slope to find a second point. So I go up 3, that is my rise, 3, and my run is 1. So from this point, the y-intercept, 1, 2, 3, and 1 to the right. So I make a point right here. Now, before you connect the dots, you also have to know if you are going to have a dashed line or a solid line. So let's look at the inequality. Inequality is greater than or equal to. That line on the bottom, it tells you that it's going to be solid. So let me write down the word solid so you remember. That's why it's solid, because you have or equal to on the inequality. So you connect the points, you make a line, and it's going to be solid just like this. Now you guys need to know what side to shade. So one way you guys can check what side to shade is the origin. You guys will check the point 0, 0. On my previous video, I show you guys how to check if a point is a solution. You substitute the numbers and you check if the statement is true. So we do have an x value, we do have a y value. So I'm just going to substitute into the inequality and check if it's true. So I'm going to have y 0 greater than or equal to 3 times x 0 minus 1. So 0 is greater than or equal to negative 1 on the right side. All of this turns into negative 1. So is 0 greater than or equal to negative 1? Yeah, it's true. 0 is greater than negative numbers. So since it's true, that is a solution. So that point right here, the origin, is really close to the line, but you can see it's on the top of the line. This is part of your solution. So you are going to shade that side of the origin. It's on top of the line, so you're going to shade all of this side over here. And let me just change the color. And you shade all the top. Now, If y is not by itself, look at this inequality, x minus 5y is less than or equal to 10. You guys need to get y by itself so we can find the slope, we can find the y-intercept, and then you guys graph the line. Now you can tell me one thing before you graph the line. What is the type of the line? It's going to be solid because you have the little line on the bottom. If you don't have the solid, the or equal to on the bottom, then it's going to be dash. So right now, the first thing is to get y by itself. So I'm going to subtract x from both sides. I'm solving for y. So negative 5y is less than or equal to. And we have the negative x plus 10. I'm going to divide by negative 5. Everything by negative 5. And this turns into 1. So we got the y. And keep in mind, here's a note. When you divide by a negative number, you have to switch the inequality. So this one, notice it's less than or equal to. I am dividing by a negative number, so I have to switch the inequality. So I'm going to turn that to greater than or equal to. So the other side, a negative divided by negative is positive. So you will have a positive 1 over 5. So let me just write that down and bring down the x. And the other one, you have a positive 10 divided by negative 5, and that's going to be a negative 2. You guys need to find the slope in the y-intercept. So y is by itself. Here's the y. So this is my slope, the one with the x, and this is my y-intercept. So we have m equals 1 over 5, and b is negative 2. So you guys will go down on the negative 2 on the y-axis right here. You guys will go up 1 and 5 to the right. Remember that we said the actual line is solid because we have or equal to. So let me write down the word solid here because we have the or equal to on the bottom. And you guys need to check what side to shade. So let me do my line first. I know this is not straight, but you guys always try to do your best. And to check, we use the origin, 0, 0. So I'm just going to substitute those values in the inequality. Now there's two things you can do. One, you can substitute into this equation. It's going to give you guys the same answer. Or you can go back to the beginning and you substitute 0, 0 into the x and the y. I like to go back in the beginning and check. It's going to give you the same answer here. And I do that because sometimes people forget to change the inequality. And when they use this to check, they get a wrong answer, wrong side to shade. So that's why I go to the beginning. So I substitute 0 into the x. So there's 0 minus 5 times 0 is less than or equal to 10. So all of this right here turns into 0, less than or equal to 10. And that is true. Since it's true, you guys will shade where the origin is at. So the origin is right here, and it's on top of the line. So I'm going to shade, and we have all of this right here. If you guys have a false statement, let's say this is false. So that means that the origin is here, but you're not shading that side. If it's false, you're going to shade the bottom of the line. That's what you check. You check if it's true or false. Now this one is actually the opposite, okay? Because they give you guys the graph and we want to write the inequality of the graph. So this is kind of like looking for the equation of the line, and then you guys need to make sense of the problem to know if it's dash, if it's shaded on the top or the bottom. So first of all, I am going to write down my slope as a form, and this is because it's a reference that I can use to write down my equation. So y equals mx plus b. We are not using an equal sign because we do have a dash line and it's shaded, so we need an inequality. But before we do the inequality, I'm just going to put a box for now, so not the equal sign. I'm going to put the y over here. I need to find my m and I need to find my b. So I need my slope and I need my y-intercept. So let's go ahead and look for the y-intercept first. That's always the easiest one to find. Notice here's the origin. We have the y-axis, we have the x-axis. So my y-intercept is right here. Let me just put a point here, and that is positive 2. Then to find my slope, I just make another point on the line, and remember that you always want to use one that crosses the corners. So this one's a good one. Just make it a point right here, and I need to know my rise and my run. So from this point, I go down and I go to the right. So I go down 1 and 1 to the right. So my slope, rise over run, is going to equal -1 over 1. Or you can say m equals -1. You guys simplify. When you're writing the equation, you don't need a fraction. You can write it as an integer, as a whole number. But when you graph it, then you guys need the rise and the run. So we have what we need. All you do is substitute -1 into the m and 2 into the b in your equation. So let's write that down. There's a -1x and there's a +2. For the inequality, first of all, notice the line is dash. So when it's dash line, there's two options. You can have a less than or greater than for your inequality. So let's think about what the shaded part means when we look at the graph. When you look at the y-intercept, which is right here, I notice that the shading part, the gray part, is on top of that y-intercept. So the y-intercept, here's the origin, is 1, 2, that's what we said, +2. So the shaded part, the gray area, is shading the number 3, the number 4 on the y-axis, the number 5, and you can keep going. So just make sense of the problem. The shaded part, 3, 4, 5, 6, 7, and it keeps going to infinity, it's actually, those numbers are actually greater than the y-intercept. And that's how you know what inequality to use. You look at the y-intercept, and if it's shaded on the top, it's going to be greater. If it's shaded on the bottom, that will be less than. So right now, I'm going to have to use a greater than. So I'm going to put y. I know what inequality I have to use. I'm just going to put greater than right here. And just to make everything look nice, I'm just going to rewrite it. Y is greater than -x plus 2. So my inequality for this graph is right here. Be careful, just a note, be careful to look at the lines always. You might have a solid line, you might have a dashed line, and also make sure you pay attention to the shaded part because it also affects the inequality you are going to use. Now this problem here is an application problem where you guys need to use inequalities and you have to set up the values and inequalities to represent what the problem is. So meaning you are going to model with mathematics. So we have Elmer Homero has almost $187 to buy a new baseball glove and a new baseball bat. Write any equality to represent this situation. So first, let's understand what we are looking at. We're looking at an amount. This person, Elmer Homero, has at most $187. Or we can say that that's all he has. He has $187 to spend. He cannot spend more than $187. So if something comes up to $190, he's going to be short. $200, he's going to be short. So it has to be $187 exactly. That's how much money he has, or less. For the two things that he wants to buy a baseball glove and he wants to buy a baseball bat. We can actually make variables. I'm going to use X and Y because those are the most common one in algebra. But you guys can use G for glove, B for bat, A, B, whatever variables. But they have to be two different ones because we have two different items. So I'm going to say X equals gloves, or the glove, he's only buying one, and the Y equals the bat. When you are going to buy those two things, a glove and a bat, and you go up to the register, well, common sense is you need to add the amount to know how much you are going to pay. So I'm just going to add the amount. I don't know what the prices are for the glove and the bat. It varies when you go to store, but I'm going to start writing X plus Y. All right, so the prices, you add them up, and we need to understand what how much we need to pay. So let's look at the word at most. This here, at most, represents an inequality. And the inequality that represents is actually less than or equal to. That's what at most means. It means that it has to be less or it can be equal to the amount. So I'm going to use that inequality. less than or equal to, so that means at most, and let me just write that down again here on the bottom, at most, so you know that's the inequality, and the amount that he has is $187. So when you see the inequality and you make sense of the inequality, you are saying the sum of the prices, the glove plus the bat, has to be at most 187. It has to be less than $187 or equal to $187. If that's true, then that Elmer Homero can pay for his items, the bat and the glove. If it's false, let's say that the sum is 200. No, he's too short. He's not going to be able to pay because he only has 187. So the answer that we're looking for is this inequality right here. Okay, guys, so this concludes my video for part 2. Make sure you guys practice, and I'll see you guys later.